All right, so this is a question from Tsokos textbook. Okay, let's first read the question and understand what it is asking for. Object is thrown vertically upwards with an initial velocity of 20 meter per second from the edge of a cliff that is 30 meter from the sea below. All right, shown in figure 2.12. Okay, determine ball's maximum height, time taken for the ball to reach its maximum height, time to hit the sea, the speed with which it hits the sea. Okay, fine. And they're asking us to take the g value to be 10 meter per second square. All right, guys. See, it is very important to appreciate or understand the fact that the equations of motions which we are going to use to solve these kind of problems can be applied only when the acceleration due to gravity is, or for that matter, acceleration is constant. So, in cases like a ball dropping scenario or a ball being tossed upwards, it is important to notice whether the air resistance is negligible or not. If the air resistance is not negligible, it means the acceleration due to gravity is not going to be constant. So if that's the case, you really can't use these equations of motion while solving the problem. Please keep that in mind. It's very important to realize or observe the fact whether the acceleration is constant. So I think left assume here that the acceleration is constant since there is no air resistance. Right. Okay, as I just told you, what is the first step is to draw a diagram so that we define the axis. Okay, that's the first step. Okay, let's do that. So by the diagram given there, let me say that the ball is okay, use blue to represent the ball. So blue. So let's say the ball is somewhere here. Okay, and let's say that the ball is thrown from origin. So this is 0. So we have got the upward to be positive x-axis. Let's say the negative is that much. And the question is also giving us that the sea is at a 30-meter mark downwards, right? So which means, let's say this is the sea level. The sea is 30 meters below 0, negative, on the negative axis, correct? And positive is on the upwards, right? So first step done. I've defined the axis. I've told where is 0. Agreed. Great. What is the second step? Second step is to, I'll write down the steps here. First step is to define axis. Second step is to write the identify. Okay. Identify knowns and unknowns. Third step is to identify the equation required. Okay, so second step, identify the knowns and unknowns. For that, I have to first read the question. The ball's maximum height. All right, so I need to find the ball's maximum height. So, A. So it's basically asking for S, correct? S at a particular instant. What is the instant at which it reaches the maximum height? So if you think about it, guys, when the ball reaches its maximum height, the velocity is actually going to be 0 meter per second. Right? Now, do I have anything else? I have the initial velocity, right? I have the initial velocity to be 20 meter per second. Since I'm taking upwards to be positive, that velocity is also going to be positive. So the initial velocity is plus 20 meter per second, right? So, but I need one more quantity to solve this equation. So I have A here, A or G, whichever, and it says it's 10 meter per second square. But the question is whether it's going to be positive 10 or negative 10. Okay, let's understand what is it going to be. Now, if you think about it, when I throw the ball upwards, the velocity should decrease in magnitude. Correct? So, and the velocity is positive here. which means if the velocity has to decrease in magnitude, the acceleration has actually should be minus 10 meter per second square. Or simply put, guys, there's a easy way to identify the sign of acceleration. The simplest way is the position. The position here being the x and acceleration, which is what? A, have the same signs. What do I mean by that? You guys know for a fact that acceleration is downwards, right? It's downwards. And what is the sign of position? I'm sorry. What is the sign of position downwards? It's negative. So acceleration is going to be negative. Right? Now let's find out what equation should I need. If you quickly recap, it's going to be v squared equals u squared plus 2as. That's the equation I will need here. So v is 0, right? V is 0. Okay, modified it. Okay, 0, yeah. Equals, so that becomes 400 plus 2 into minus 10 times s. So basically 400 minus 400 equals minus 20s. So minus minus cancels out, so 1 cancels out. So s comes out to be 20 meters. So which means that's the maximum height the ball reaches from the point where it is thrown from the cliff. This is the point from which it is cliff thrown, right? Let's say x. So that's problem number A. What about problem number B? Problem number B is asking of the time taken for the ball to reach its maximum height. The time taken, right? So it's basically, so the unknown here is t. Right? Let's quickly list down the knowns. So I know the final velocity to be 0 because it's still asking for the time for it to reach the maximum height. That's 0 meter per second. I know u to be by 20, right? It's 20. So I have 20 meter per second, and I just now found s to be 20 meters. So if you quickly recollect, the equation which we can use is s is equal to u plus v. Sorry, u plus v into t by 2. So need time, correct? So you get 20 times 2 equals, so v is 0 basically, correct? V becomes 0. So you get 20 times 2, and u is, okay, that becomes 20t. So 20 cancels out. So you get t is equal to 2. So basically, this means at t is equal to 2.0 second, the ball reaches maximum height. But since we have assumed that the ball is thrown at time t is equal to 0, the time taken for the ball to reach the maximum height also becomes 2 seconds. All right, so that's done. So now C. What is C? Okay, the C question is time to hit the C. This is a tricky one because it's going to go up. I have to draw it here. The ball is being thrown up, right? So which means basically the ball is traveling up by how many meters? 20 meters. And it's coming down by the same distance. And then it's going to plunge into the sea. So we'll have to be very careful with this question. All right. So the question is for time. Time here again, but to hit the sea. Right. Now, there are two ways of solving this problem. One is to break the motion into two. One being going up and coming down, and the second half being for the motion from the 0 meter mark until it hits the sea. That's one way of doing it. The second is you don't even have to break it. Okay, you can actually do it in one go. So I'm going to teach you the second method because that's not going to take you much time. Right. Okay, since we know the unknown, let's quickly identify the knowns. Now what are the knowns? The initial velocity being plus 20 meter per second. Do I know the final velocity? Now, if you guys think that the final velocity to be zero, you're mistaken. Because the final velocity is always the velocity which is attained by the ball just before hitting the ground. So that velocity is going to be the maximum velocity, not zero velocity, right? And I don't know that velocity. I don't know what is the final velocity going to be. I don't know that, right? Okay, let's think of acceleration. Acceleration, as I told you, is in the same direction as the position. So acceleration due to gravity is downwards. Its acceleration due to gravity is going to be downwards, and the position is also negative downwards. So which means the acceleration is going to be minus 10 meter per second square. But still, this is not enough. I need one more variable so that I can solve this problem. Is there anything else which I can know? If you look at it, what is yes? What is yes? Yes is nothing but change in position or displacement. And what is the formula for displacement? It's final position minus initial position, right? And the initial position is zero. The ball is starting from zero, correct? As I told you, that's how we make an assumption, right? We make an assumption that the ball is starting from zero all the time, right? Now the final position, it's actually negative, right? Final position is minus 30 meter, which means S has to be also minus 30 meter, right? That's the sea level, right? So now I have all the quantities necessary. So what's the equation involved? What is the third step? Find the equation. So by looking at these, you can quickly realize that the equation involved is S is equal to ut plus of t squared. So S is minus 30, right? And it becomes 20t minus half into 10 because this minus is coming over here, t squared. So I get minus 30 equals 20t minus 5t squared. So if I can rearrange this, 5t squared minus 20t minus 30 equals 0. So this is a quadratic equation, right? And if you solve the equation, you must get the answer now. Let me share the textbook with you guys so that you guys can see it. Right. So you see, so that's the equation. So if you solve the equation, you get 2 times, one being negative and one being positive. So we take the positive time. So this is the time. So again, as I just told you, this means at 0.52 seconds, the ball hits the sea. Right? Okay, let's do the last one. What's the last question? I think it's the speed with which it hits the sea. The speed, now look at the word, it's speed. They're not asking for velocity. They're asking for speed with which it hits the sea. So which means we basically have to find the final velocity and then just express it in terms of magnitude only. Right? Agree. So let's go back now. So last question. E part. E part. So the question is asking for V, right? And I know the displacement to be minus 30 meters, right? And I know acceleration to be minus 10 meter per second squared. And I know U to be 20 meter per second. In fact, I also know the time taken. We just found it out. We also just found out that it is going to take 5.2 seconds from initial position until it hits the sea. Right? So we can actually use more than one equation to solve this problem. Okay, I'm just going to go with this now. So what is the equation involved here? It's going to be v squared equals u squared plus 2as. So v squared is the unknown here. this becomes 400 minus, or rather, okay, plus 2 into minus 10 into minus 30. Okay, so I get 400, that becomes 300. So minus of 600. Square root of 1000 approximates to 32 meter per second. So minus 32 meter per second. But since the question is asking only for speed, we can safely ignore it, and answer can be written as 32 meter per second. This is how you solve problems, guys. Please remember the first three steps. Those are crucial, and you must also be careful while finding the direction for acceleration. The easiest way to do that is to assign the sign of the position which you're taking downwards. If you're taking downwards to be negative, acceleration is going to be negative. If you're going to take downwards to be positive, acceleration is also going to be positive. Simply put. Thank you.